Good morning, sir. Myself, N. Devi. I am from ECE. My roll number is 234G180432 and the subject name is Analog and Digital Communications and the topic name is Amplitude Shift Keying. And the amplitude shift keying in briefly explain about cohort detection, working, waveform analysis and applications. First we can go through the introduction to amplitude shift keying. Amplitude shift keying is a form of digital modulation that conveys data by varying the amplitude of a carrier wave. It is commonly used in applications such as radio communications and data transmission. Understanding amplitude shift keying is essential for grasping more complex modulation schemes used in modern communication systems. Basic principles of amplitude shift keying. In amplitude shift keying, binary data is represented by two different amplitudes of carrier signal. A high amplitude typically represents a binary 1, while a low amplitude represents a binary 0. This simplicity makes the amplitude shift keying an attractive choice for low bandwidth applications. Next, we can go through the coherent detection overview. Coherent detection is a technique that requires a reference signal to decode the transmitted information. This method allows for improvement sensitivity and performance, especially in noisy environment. Coherent detection is essential for accurately demodulating amplitude shift keying signals. Working of coherent detection. The process begins with mixing the incoming amplitude shift keying signal with a locally generated reference signal. This mixing operation produces a baseband signal which can be filtered and analyzed. The output is a recovered data signal that can be further processed to retrieve the original information. Next, waveform analysis of amplitude shift keying. The diagram shows the waveform analysis of amplitude shift keying. The amplitude shift keying waveform consists of pulses that represents the two distinct amplitude corresponding to binary states which has zeros and ones. The time duration of each clock pulse is critical as it defines the bitrate of the communication. Analyzing the amplitude shift keying waveform helps in understanding its spectral characteristics and performance matrices. Next, we can go through the spectral characteristics of amplitude shift keying, and the diagram shows the spectral characteristics of amplitude shift keying. The frequency spectrum of amplitude shift keying can be determined by the pulse, shape and duration. Amplitude shift keying typically exhibits a sine function shape in the frequency domain, which can lead to spectral spreading. Understanding the special characteristics is vital for channel allocation and interference migrating. Advantages of amplitude shift keying. Amplitude shift keying is to implement requiring minimal criticality compared to more complex modulation schemes. It has a relatively low power requirement, making it suitable for battery operated devices. Amplitude shift keying can achieve high data rates, overshoot distance, particularly in line of sight communications. Next, we can go through the disadvantages of amplitude shift keying. One major drawback of amplitude shift keying is its susceptibility to noise, particularly amplitude modulation fluctuations. The performance degrades significantly in multi-path environments, leading to errors in signal detection. Amplitude shift keying is a less efficiency in bandwidth usage is compared to other modulation techniques like frequency shift keying. Applications of amplitude shift keying. Amplitude shift keying is widely used in optical communication system for data transmission over fiber optics. It is also prevalent in RFID systems for short range identification and tracing applications. Additionally, amplitude shift keying can find applications in amateur radio and low power radio frequency communications. Amplitude shift keying in digital communication systems. In digital communication system, amplitude shift keying can be used for transmitting binary data and over analog channels. It is often employed in conjunction with error correction techniques to enhance reliability. The adaptability of amplitude shift keying makes it a suitable choice for various digital communication standards. Modulation schemes comparison. When comparing amplitude shift keying to module schemes, it is important to consider trade-off its complexity and performance. Quadrative amplitude modulation can offer higher data rates but requires more sophisticated demodulation techniques. Understanding these comparisons helps in selecting the appropriate modulation scheme for specific applications. Next, we can go through the future trends in amplitude shift keying. Research is ongoing to enhance the robustness of amplitude shift keying against noise and interference. Emerging technologies and exploring hybrid modulation schemes that combines amplitude shift keying with other techniques for improved performance. The development of advanced signal processing algorithms is expected for future or further enhance the effectiveness of amplitude shift in modern systems. Summary of key points. Amplitude shift keying is a fundamental modulation techniques used in various communication systems. Coherent detection plays a critical role in improvement the reliability and performance of amplitude shift keying. Despite its limitations, amplitude shift keying remains relevant due to its simplicity and lower power requirement. Conclusion. Amplitude shift keying continues to be an important modulation method in digital communications. A comprehensive understanding of its principles and techniques is crucial for engineers and partitionally. As the technology evolves, amplitude shift keying may adapt and integrate with the new methods to meet future communication demands. And questions and discussion. Thank you for attention and presenting with amplitude shift keying. Thank you, sir.